Hi. Now if you want to revise the trapezium rule, then this is a good question to do. What we've got here is an equation of a curve with the equation y equals x to the power half multiplied by the natural log of 2x. And we've got this finite region here R, which is shaded and is bounded by the curve, the lines x equals 1 and x equals 4. And also the x-axis. And what you've got to do is use the trapezium rule with 3 strips of equal width to find an estimate for the area of R, giving you answer to 2 decimal places. So if you haven't tried this already and just want to give it a go, just pause the video, come back when ready, and you can check your work solution with mine. Okay, welcome back if you had a go. So we need to divide this up into 3 strips of equal width. So that means that there'll be 1 strip there, 1 strip there, not necessarily in my sketch of equal width, but the intention was there. So this would have to be x equals 2, this would have to be x equals 3. Okay, so we have our 3 strips here. Now you can see that the width of each strip is going to be 1 unit. And I would always suggest when you're using the trapezium rule just to draw a sketch so you can see what that width is going to be. Okay, so what is the trapezium rule? Remember, you can always get tutorials on this on my website, ExamSolutions.net. But briefly, what we have is that the area is approximately the same as the width of any strip. Okay, they're all going to be equal, and that width in this example is going to be 1, divided by 2, and then you do the first height, that would be this height in this example, plus twice the sum of all the middle heights, so we'd add these heights together and then double them, and then plus the last height, this height up here. Alright? So if we apply that rule then, what we're going to have is that the area, let's just put it here, is going to be approximately then the width of the strip divided by 2. Well, the width, as I say, is going to be 1 unit, and we divide that by 2. Then I'm going to put a big square bracket here, and we've got the first height. Well, the first height is the one where x is 1, and we just substitute x is 1 into the equation of the curve. And when x is 1, you're going to get 1 to the power half. Well, that means the square root of 1, which is 1, multiplied by the natural log of 2 times 1. So really this is just going to be the natural log of 2. I won't bother working that out as a decimal, it just takes too long. Okay, we can do that at the end. And then it's plus 2 times the sum of the middle heights. So we've got this height first of all. So when x is 2, we've got 2 to the power half, which is root 2, multiplied by the natural log of 2 times 2, in other words the natural log of 4. So we have root 2 times the natural log of 4, plus the next height when x is 3, so we've got 3 to the power half, which is going to be root 3, and we multiply by that by the natural log of 2 times 3, 6 in other words, natural log of 6. So that's twice the sum of the middle heights. Now we just have to add the last height when x is 4. And when x is 4, we've got the square root of 4, which is 2, multiplied by the natural log of 2 times 4, which is 8. So you've got 2 multiplied by the natural log of 8. And all you've got to do is now just put this through your calculator, okay? And so it saves time writing each one of these out in decimals, just to leave it in this form and just do it in one go on your calculator. If you do that, you'll find you do get 7.4899 and so on. Okay? And we're asked to give our answer to 2 decimal places, so to 2 decimal places the area then is going to be approximately 7.49. Okay, we could put units squared. You don't have to put that. It's okay, you're not going to lose marks if you don't put that in, but it is an area and I often prefer to write that. But anyway, the accuracy is to 2 decimal places, 2 dp. Okay, so it's giving you an idea if you were stuck on that.